Welcome everyone. In this video lecture, we will solve a rectifier circuit problem, which is basically from the Microelectronics circuit book. So the question is, a full wave bridge rectifier circuit is given with a 1 kilo ohm load. Okay, so this R value is given 1 kilo ohm load. Okay, operates from a 120 volt RMS 60 Hz household supply. So this one we can say this one is the primary voltage across this step down transformer. So I am saying this is a primary voltage VP. Okay, 10 to 1 a step down transformer. Okay, having a single secondary winding, it uses 4 diodes. So bridge rectifier it uses 4 diodes, each of which can be modeled to have a zero point 0.7 volt drop. Okay, so basically we can say this one is a silicon diode, so which having a 0.7 volt drop for any current. So we have to find the peak rectified output voltage across the load. Okay, we have to find the peak rectified output voltage across the load. For what fraction of cycle does each diode conduct? We have to find out the fraction of cycle of a cycle for each diode. What is the average voltage across the load? Average voltage across the load and the average current through the load we have to find. So first of all, this VP is given primary voltage for this step down transformer. So we have to basically first find this secondary voltage, or we can say this Vs. Okay, so this Vs can be simply find out by using formula primary voltage by N2 by N1. In my old video I have mentioned the formula also, so I have just used that one. So this will give the 120, N2 is 1 and 10, so this should be our 12 volt RMS. Okay, so this value is equal to simply 12 volt RMS. Okay, so I am not writing here. Okay, so this value is our 12 volt RMS, and we are saying that this one is a sinusoidal signal. So we are just finding the Vs peak. So Vs peak equals to Vs RMS into root 2. So I am writing like this, Vrms into root 2. So it should be our 12 root 2 volt. 12 root 2 volt is the secondary voltage, okay, across this one. So now this is our prime concern, Vs. So this I have already draw. So this I am saying this one is a Vs with some function theta. Say this should be our pi 2 pi, and say this one is our 3 pi, and this Vs peak is our 12 root 2. So this height, okay, I make some thick, so no need to worry. So this height is our 12 root 2, and this height will be minus 12 root 2. Okay, or you can write here also 1 plus 12 root 2. Okay, so it will be better to write here. You can. Okay, so this one is our voltage Vs. So now what we can say, again this one is our bridge rectifier. So I'm just again drawing the same circuit here. Okay, so now instead of this one we can remove this one, no need to make the transformer. Okay, and what we will do, this one is our plus or minus Vs. We can say that this one is our primary connection. Now we have to look for the this solution, means what should be the maximum rectified output, all these things. Okay, so in the question it is given zero point 0.7 volt voltage drop across each diode, and basically we can say this one is a silicon diode. So we know the full wave rectifier concept. So what we will doing, the very first step, what we can do, if we are giving the positive half cycle, this one, say 0 to pi, okay, so in between 0 to pi, in the first half cycle, 0 to pi, okay, vs, the diode d1 and d3 will be in the on state or in the forward bias condition, okay. So when this d1 and d3 will be the on state, so one, I'm just making this as a short, okay, or we are just short, okay, so this is just short, okay, but the voltage drop, okay, so more simplified diagram I have to make, means for this one, okay, and another thing, d2 and d4 will be in the off, okay, or open circuit. So what we can do, this working I'm going to discuss, it will take 2 3 more minutes, but okay, I will complete that one first, okay. So here for the positive half cycle, this d1 will be conducting, okay, so this d1 will conduct, so here what we can say, we can put this as a 0.7 volt, okay, and this d4 and d2 will be off, okay, okay, and instead of this one, we can also make it, okay, 0.7 volt, okay. So when we are giving input like this, first positive half input for 0 to pi, the d1, the d1 and this d3 will conducting, and this will be the path, and we will get the output voltage. But in this case the output voltage will be, we have to find, okay. So before that, there is also one concept of transition voltage, okay, above which diode will conduct, basically for which diode will conduct, not only for 0 volt or zero point 0.7 volt it will conduct, okay. So that transition voltage we have to find. So I'm writing, I have already discussed this transition voltage concept, okay. So in this case what we are doing, we have just saying this one is our vs, okay, and this one is 0.7. So in transition voltage, our d1 and d3 just on, okay, and current across the load will be 0. So this current will be 0, okay. So if we apply kvl in this loop, okay, one can write vs minus 0.7, then it should be 0 because I is 0, r is 0, so no need to write minus 0 minus 0.7 equals to 0. So vs minus 1.4 equals to 0, so vs equals to 1.4 volt. So this one is one very fundamental or very important relation, means it will gives the transition where we have to minimum value when the diode will be on or off, okay. So minimum value we have to give, so this vs equals to 1.4, equation came, okay. So that vs equals to 1.4 line we have to draw, So this line I am saying 1.4 volt. So after that, this Vs 1.4 volt, we will get the output. Okay. So when the Vs is greater than 1.4 volt, diode D1 and D2 conduct, because zero point 0.7 volt voltage drop is there, zero point 0.7 volt voltage drop is there. So maximum we have to give minimum voltage we have to give 1.4 volt when the both diode D1 D2 conduct. Okay. So for Vs greater than 1.4 volt, D1 and D2 conduct. Okay. So during that time, I am saying this point is our theta, and this point is our this point is pi minus theta, and at this point the output will be 0. Okay. And the maximum value of the output we can easily find from this equation, from this circuit. I'm just again making the same circuit here, because this portion is very important. Plus of minus, this one is Vs, this one is D. Okay. So what we can do? Okay, these two will be open. So the value of the output voltage we can easily find by just applying KVL in this loop. So one can write Vs minus 0.7, because this one is our simple zero point 0.7 volt voltage of zero point 0.7. So minus 0.7, and this one minus V naught minus 0.7 equals to 0. So the V naught will be Vs minus 1.4 volt. Okay. So the peak value of the output voltage will be Vs. Okay. So Vs peak will be our 12 root 2. We have already written minus 1.4. So 12 root 2 minus 1.4, if we solve, it will come 15.57 volt. So this one will be the V naught peak. Okay, so this value we can easily find. Okay, by using this Vs greater than equals to 1.54 should be. So V naught, when 1.4 voltage, the output voltage will be just 0. Okay, so we very much familiar about the simple, what we can say, the bridge wave rectifier output or full wave rectifier output. So this point you can say like this. Okay, and after that it should be 0 here, here also. So for the negative half, again if we do like this, for the D2 D3, one more line will come like Vs equals to minus 1.4. Then again for this point, again it will go up. Okay, so I'm not just telling the this point. Okay, this was the output waveform. Okay, this one is simple full wave rectifier output waveform. So our primary concern. Okay, so similarly for D2, D for D2, if we negative one, we can also write a reference line. Then after above this diode means diode D1, D2 on or off, and then if we plot the output waveform, it will come like this. Okay, this was a very fundamental one. So I am not going to discuss the other part. You can also draw the output waveform easily, even as per your own convenience, by any method you can do, but I am following this method. So now this picture is clear. So now we have to find the theta value. So what we can say, this curve is our 12 root 2 sine theta, means basically the Vs value is our, so first portion of this one, a part we can say peak value is over. Okay, so the first one we can, why I am saying this one, peak rectifier output, so I am saying A. Okay, B we can say this edges C and D. Okay, 4. So now we have to find the theta value. Okay, so for that thing, what we can say, 12 root 2 sine theta equals to 1.4 will give the theta value, because this 12 root 2 sine theta is intersecting with this Vs equals to 1.4 line. So this point we can easily find. So by this one we can find sine theta equals to 1.4 by 12 root 2. Okay, then after we can find sine inverse 1.4 by 12 root 2. So I have already calculated. If we calculate, it will come 0.0825 radian. I am calculated using radian, so it should be 0.0825 radian. Okay, so the theta value is our 0.0825 radian. Okay, so this one is one of the important result. Now pi minus theta we can also write the theta value is, okay, I am just showing you where the theta value is there, this theta value. So now this point is our pi minus theta, the other point is our pi minus theta is the other point, another point. Okay, so what we can do, the in the first cycle, in the first cycle, means theta in between 0 to pi. Okay, means angle, we can say angle in confusion, so make it phi or anything, means for the region 0 to pi. Okay, or in between t, if we say omega t, so when omega t in between 0 to pi, the conduction angle for the first half, okay, in the conduction angle will be pi minus theta, that is our pi minus 2 theta, means this distance is our, I am saying, conduction angle pi minus 2 theta we can say. Okay, pi minus 2 theta. So now the total conduction angle for the full cycle, so we can write, I am doing for part B, total conduction angle for full cycle, we can simply say we have to multiply by 2 pi minus 2 theta. Okay, because this one for the first half cycle, for the next one also this should be pi minus 2 theta. Okay, so simply we have to make it double, so 2 pi minus 2 theta. So now we can easily solve, we can have to write in the radians, so 3.14 minus 2 into 0.0825. I have already solved four more problem before that problem, so you just go through all problem, then your concept will be more clear. Okay, 2.975 if you solve, so it will come 5.95 radian. Okay, so basically we have to find the percentage, means how much percentage the conduction. So what we can say, in a 2 pi period of the signal, in that time the conduction is 5.95 radian. Okay, so in 101 we can write by unitary method 2 pi into 100. So it will come nearly 94.67. Okay, 697 or simply 94.7. Okay, 7% the conduction. Okay, so this one is the fraction of conduction. Okay, now we have to find the C average output voltage, third part. Okay, B part is clear. What is the average value of across the load, average one? So we have to find this area and this area. Okay, so I average or V average we have to find. So first average one, average output voltage, first voltage we have to find. For the average output voltage, what we can do, we can write V naught average we have to find. So period of the signal 1 by 2 pi. Okay, so I am writing multiplying with 2 theta to pi minus theta. Now what we have to write, the curve equation we can write it 12 root 2 sine phi minus 1.4 d phi. Okay, because this curve we have to find the area of these 2 points. So this curve will be 12 root 2. I am saying sine theta minus 1.4. So basically this one. So this one is go drop by point 1.4 down. Okay. So 12 root 2 is this one minus 1.4. So this equation for this curve will be 12 root 2 sine phi. Okay. So now if you integrate 0 to pi minus theta for this one, so we are not, so we have to integrate, so we are just making it as phi. Okay, therefore and then theta to pi minus theta. Okay, simple mathematics is there. So one can simply write 1 by pi, these two cancel, theta to pi minus theta, one can write 12 root 2 sine phi d phi. Okay, plus, oh sorry, minus 1 by 4 d5. Okay, one more line I will write. Okay, now we have to solve this one. Okay, so what we can do, we can simply write 1 by pi 12 root 2 sine phi. Okay, so one can take 12 root 2 and in bracket we can write minus cos. Okay, minus cos phi sine phi minus cos phi pi minus theta to theta minus and then integration of 1.4. So 1.4 phi pi minus theta to theta. Okay, means the, we have to just do the integration. So one can write minus 12 root 2 by taking minus common. So cos pi minus theta minus cos theta. Okay, cos pi minus theta is a minus cos theta. Okay, so one more line I will write minus 1.4. One can write pi minus theta minus theta. Okay, so this is simple calculation. So cos pi minus theta will be minus cos theta, minus cos theta minus cos theta minus 2 cos theta. So one can simply write 24 root 2 cos theta. Okay, because this whole term will be now minus 2 cos theta. Okay, then minus 1.4 pi minus 2 theta. Okay, so now we have to put the value. So what we can write 24 root 2 cos 0.0825. Okay, nearly 0, so it value will be 1. So directly 24 root 2 minus 1.4 pi minus 2 theta. Have you calculated pi minus 2 theta? Okay, pi minus 2 theta is this one. So 2.975. So and 2.975. Simple calculation is there. So if we solve this one, 24 root 2 cos, this value will be nearly 1. So 24 root 2 minus 1.4 into 2.975 will be 4.165. Okay, so this value will be 1 by pi. If you solve 29.7761, and it will come nearly 9.47 volt if you solve this one. Okay, so this one is the V naught average voltage. Okay, now the last part, average output current. For the average output current, I naught average equals to V naught average by R. So this should be 9.47 volt by 1 kilo ohm. So 10 to the power 3, so it should be 9.47 milli ampere. Okay, so this is the result, final answer for the output current, and output voltage will be 9.47, and the fraction of a full load 94.7% utilization of the input waveform. So the conduction for the first half pi minus 2 theta, for the full cycle pi minus 2 theta. Okay, and this one is the way to, I think you can easily draw by any means how to, for this area. So we have to find the area. So we are basically concentrating on this, and by multiplying to, you can easily say. So like that we can solve this problem, and this is from the microelectronics circuit book. So this is all about this question. So thank you for watching this video.